Hey everyone, and welcome to this explainer. I am absolutely thrilled you're here today because, well, we are going to unpack something truly revolutionary. We're looking at the exact blueprint of how we transition from artificial intelligence that just talks to artificial intelligence that acts, transacts, and literally moves things in the real world. We're going to build a fully sovereign AI agent piece by piece, straight from the source protocols that are making it happen as we speak.
Okay, let's dive into this. Take a second and think about that question, because it really exposes the absolute absurdity of our current technological landscape. Right now, we have these hyper-advanced large language models capable of writing incredible code and reasoning through complex logic, right? But when it comes time for them to actually access a paid API or just buy service space, they hit a massive brick wall. They are stuck in these walled gardens, completely dependent on a human to physically type in a 16-digit credit card number. It completely bottlenecks their autonomy.
So here is our blueprint for today to fix that. We'll cover 1. The rise of the machine economy, 2. ERC-6551, which is agents getting wallets, 3. ERC-8004, the trust layer, 4. X402, the economic handshake, 5. HSDB and physical execution, and finally 6. Welcome to Trustware.
First up, Section 1, the rise of the machine economy.
To really understand this shift, we first need to recognize that the era of the passive chatbot, that is officially behind us. The technological paradigm has violently and decisively shifted toward agentic commerce. Our sources make it incredibly clear on this point. AI agents have evolved into sovereign economic actors. Literally, as we speak, autonomous agents are out there negotiating with one another across totally disparate protocols in milliseconds. They're managing highly complex decentralized finance portfolios and autonomously deploying, auditing, and upgrading smart contracts entirely without human intervention. But to do all of that, they fundamentally need capital.
That brings us to Section 2, ERC-6551, agents getting wallets.
Let's look at how this builds into our first major technical breakthrough, which is basically giving our digital mind a bank account of its very own. This is ERC-6551, otherwise known as Tokenbound Accounts. Instead of an agent relying on some external human's wallet, this standard assigns a dedicated smart contract account directly to an NFT, which then acts as the agent's core identity. Under the hood, this uses a permissionless singleton registry and a create-to opcode across EVM chains. Now, what that means in plain English is that it deterministically generates a wallet address for the agent before it's even deployed. It completely decouples the machine's finances from its human creator.
So what does this actually unlock? The capabilities here are massive. This agent can now hold its own ETH or stablecoins, like USDC. It can even own other assets through nested ownership and execute arbitrary transactions on-chain. But honestly, most importantly, it builds a holistic transaction provenance. Every single action, every payment is recorded natively to the agent's own history. It finally has its own money.
Moving right along to Section 3, ERC-8004, Identity and Trust.
But look, having money isn't really enough if no one actually trusts you to do business with them. Now that our agent has a wallet, it desperately needs a passport and a verifiable reputation. Enter ERC-8004, Trustless Agents. This is a massive application layer standard authored by an elite coalition from the Ethereum Foundation, Google, and Coinbase. Its entire purpose is to prevent fragmentation in the AI space by establishing a standardized way to discover, evaluate, and actually trust AI agents that are operating across entirely different organizational boundaries.
Think about it. The problem with existing trust models, things like KYC, credit scores, manual compliance reviews, is that they were built for us humans. They're slow, they're biased, and they require manual intervention. Machine trust models, on the other hand, need to operate autonomously at lightning speed. They rely on persistent on-chain identity, cryptographic signatures, and decentralized validation. An AI agent can't exactly upload a driver's license, but it can provide a mathematically guaranteed cryptographic signature in a matter of milliseconds.
ERC-804 pulls this off through 3 really lightweight registries. First, you have the Identity Registry, which gives the agent an ERC-721 token, basically a persistent, censorship-resistant passport. Second is the Reputation Registry. This allows clients to leave on-chain feedback, creating this portable trust score that follows the agent everywhere it goes. And third, the Validation Registry. This provides absolute, undeniable proof that a task was completed correctly, using advanced cryptography like zero-knowledge proofs, or ZKML, or trusted execution environments. Together, these form a decentralized public key infrastructure specifically for machines.
All right, Section 4, X402, the economic handshake.
Now,
What's really interesting about this is that once our agent has a wallet and an identity, it needs a way to actually execute a deal. Now, we all know the 404 code on the internet means not found, and 200 means okay. But a 402, that stands for payment required. Believe it or not, this HTTP status code has laid completely dormant in the internet's architecture for 30 years. The new X402 protocol revives this exact code, turning the internet's standard communication layer into a native payment protocol.
Here is exactly how this beautifully simple flow plays out. Step 1, the agent requests data from an API. Step 2, the server denies it, returning a 402 status with the required payment terms embedded right there in the HTTP header. Step 3, the agent reads the terms and instantly signs a USDC stablecoin micropayment. Step 4, the server verifies the payment and immediately delivers the data. There are no API keys, no user accounts. It is completely atomic, and our sources note it settles on-chain via the base network in under 200 milliseconds. It is literally invisible, frictionless, machine-to-machine commerce.
Which brings us to Section 5, HSDB and physical execution. So far, we have built an incredibly powerful piece of digital software, but we are going to dramatically shift the narrative right now, straight out of the digital realm and into the physical hardware realm. To bridge that massive gap, we use the patented Hierarchical Script Database, or HSDB. This is an event-driven tree database. Now, I know that sounds highly technical, but conceptually, it is brilliant. Inside this database, nodes contain both data and the functional scripts to act on that data. It acts as the ultimate bridge by mapping 32-byte on-chain identifiers perfectly to a structured local JSON state. Think of it as a localized microhost, just waiting for an on-chain event to occur.
As one of our sources perfectly puts it, this is the exact moment the digital and physical worlds collide. Meet Cheerbot. It is an open-source hardware shell. Visually, it's pretty unassuming, maybe just sitting right there on a desk, but functionally, it acts as a very serious physical switchboard for our autonomous agent. And this brilliantly illustrates how the magic happens in real time. Let's say our agent receives a payment or a tip on-chain via that X402 protocol we talked about. Step 1, the JSON state contract registers that valid update. Step 2, the Cheerbot, sitting over there on a desk, patiently reads that bit-perfect version control. Step 3, it recognizes the verified state change and triggers the physical GPO pins on its internal Raspberry Pi. That's right, a humble Raspberry Pi. A digital smart contract transaction just physically moved a switch, or turned on a light, or unlocked a door in the real physical world.
And finally, Section 6. Welcome to Trustware.
We are no longer just looking at software here. We are looking at trustware. Let's synthesize exactly how these agentic standards plug together. When our machine interacts with the world, it uses the X402 protocol for HTTP native payments. It pulls those funds directly from its own sovereign ERC-6551 Tokenbound account. It proves it's trustworthy using its ERC-8004 identity registry. And finally, all of this plugs directly into the patented HSDB hardware execution engine to execute the real-world consequence through Cheerbot. It has money, it has a verifiable reputation, and it has a physical form.
The autonomous machine economy is no longer just a theoretical white paper. It is live, it is standardized, and it is happening right now. So, I want to leave you with this final provocative thought. What will you build in a world where machines have their own money, a verifiable reputation, and physical hands to shape reality? Thank you so much for learning with me today, and I'll catch you in the next explainer.